Part 2 of the video, we're going to be talking about how to actually use what we learned in Part 1 to control things. So what you're going to need, at least in this example, is wires going from the receiver to the Arduino. You just need one channel for this. Then you're going to need whatever you want to control. For instance, I'm using a relay because this lamp pulls too much current for the Arduino to output through its signal line. So I have gotten this relay, and it has the two coil pins that engage the relay are connected between the ground and signal pins of port 3. And then I've put the input line just going to a power supply, and then the negative end of the power supply goes to the lamp, and the lamp is connected to the pin that is off when the relay is off. And then that pin, when the relay is energized, goes hot, and this lamp should turn on. So let's go through on the computer and see how we do that. Alright, so here we go. This is the code that's going to be using. We're still using the throttle variable from last time, just so that it's the same throughout all these videos. Still on pin 13 as the input, but this time we are putting pin 3, which is the one the relay is connected to, as an output, and then you have to make sure on startup it writes it as low. Don't worry about writing in the serial commands and all of that unless you want to use it for testing. And then in the loop, we do the same thing where we define the variable as this, which will give us a 0 to 100 value. And then you just do a couple if statements and say if the throttle is greater than 50, meaning I raised my throttle above 50%, it will then write digital 3 as high, which will then turn the relay on. And then you do another one and say if it's less than 50, it will write it as low and turn the relay off. So let's go ahead and upload this. And now let's see if it works in the real world. So now what we have, the computer's not plugged into it just because the relay does draw a little bit of current from the Arduino, and sometimes my computer can't keep up. There's a weird bug every so often. You just might have to adjust values for this, that randomly it will think it's lower or higher than it actually is, and the variables will bug out and make it flash as you just saw. But you see we have our power supply running into this. So it did just flicker again, and the way you change that is by slightly raising the throttle above 0, but not all the way up to 50. As you can see right now, it is at 84, or negative 84 instead of negative 100. So now, as I raise my throttle above 50%, the lamp turns on. Bring it back down, lamp turns off. And this code works like stacking, so you can have like multiple outputs and stuff like that. And let me show you what some other things you can do with it. What about stage lighting? Yes. So this is the code I use to control a NeoPixel lamp with a transmitter. And all it really is just a code for, it's the same basic idea as the other one, except it has 3 states, and I have not done the division so I can get a slightly larger range. And so if the throttle is less than 200, meaning it is a low value, it clears it, and then it updates the system. And if it's between 200 and 600, it goes into what is the like orangish glow, and then it updates it. And then if it's greater than 600, meaning it's like all the way up, it is
a larger value, or it goes into a blue mode. Some things to note is that the reason it was flickering earlier in the video was because of the division. The division is just to show you the concept. Sometimes it bugs out with just like it overflows the Arduino's buffer just because of so many decimal places. So usually when I'm doing large amounts of code that has to do other things, I often just ignore the division and just get the value lower so that I have a better range. And so let me show you what that looks like in the real world.
Again, we have the Arduino and receiver set up the same way, except on pin 7, and we have a set of NeoPixel LEDs inside of a 3D printed housing. And so now what I do is, if I raise the throttle, it goes into orange, and then goes to blue. Then I can bring it back. When I had the throttle tied to a switch, it made it much more reliable and much faster, which is what I did when I used this as a prop during a show for like a street lamp. And it's some pretty basic code. It works pretty well. And when using this model receiver, if I was to cut power on the transmitter while this is working, so you see the receiver's lamp is on, the transmitter lamp is on. If I cut power to it, the receiver takes a second to turn off sometimes, it goes off. That is because the receiver defaults the value to 0. And that is the standard safety mode it has set up. And so yeah, let me show you some other things you can do with it. My ceiling fan. Check. A 20,000 volt generator. Check. A very dangerous laser tube driven by a high voltage generator. The relay is being messed up by the high voltage. I guess it works.